We're going to aim in part 1 as if we are trying to solve for the x-coordinate of d, because along the way, we will be able to form an equation such that the x-coordinate of d will satisfy. So the first thing that I'm going to do is I'm going to form the equation of the line BD since it passes through the point D. So to do that, I will first need the gradient. So the gradient of the line that passes through BD will be equal to 6 minus 5 divided by 5 minus 7, and this is equal to minus half. So the equation of this line that passes through BD will be, if I were to make use of the point B, it will be y minus 5 is equal to the gradient, which is minus 1 over 2 of x minus 7. Rearranging this, we will have y to be equal to minus 1 over 2x plus 17 over 2. This will be equation number 1, an equation that has the xy coordinate of d within it. And the next thing that I'm going to do is I'm going to work on the parameter. Since the question tells me that the parameter is equal to 46, and the parameter composed of 2 times of AB, since this is a parallelogram, 2 times of AB plus 2 times of AD. So for the length AB, we can actually do a calculation for it. So for the length AB, if I were to take the coordinates of these 2 points, it will be 7 minus 5. So I have this square plus 5 minus 0 square. And this is equal to 13. And for AD, since we don't know the coordinates of D, I'm going to just assume that the coordinates of D is x, y. So by making this assumption, AD will be equal to square root of, if I were to make use of this coordinate and this coordinate, it will be square root of x minus 5 square plus y minus 0 square. And this will be equal to square root of x plus 5 square plus y square. So the parameter, which is given to us as 46, which composed of 2 times of AB and 2 times of AD. So this will give us 46. So we have a 2 times of AB, so 2 times of 13, plus 2 times of this, which is square root of x plus 5 square plus y square. This is equal to 46. Dividing by 2 throughout, we have a 13 plus square root of x plus 5 square plus y square. This is equal to 23. Bring 13 over to the other side. So on the left hand side, we will have square root of x plus 5 square plus y square is equal to 10. And squaring both sides, x plus 5 square plus y square, this is equal to 100. This will be equation number 2. So I'm going to try to solve for these 2 equations simultaneously, coming up with an equation that is x. So I'm going to try to solve for the x coordinate of d. So to do that, I'm going to substitute equation number 1 into equation number 2. So substituting this into this, we have x plus 5 square plus y, which I'm going to replace it by minus half x plus 17 over 2 square. This is equal to 100. Expanding this, we will have x square plus 10x plus 25. Then expanding this, it is going to be 1/4 x square plus 17 over 2x plus 289 over 4. This is equal to 100. So simplifying this, we will have a 5 over 4x square plus 3 over 2x, and this is equal to 11 over 4. Then multiplying throughout by 4, we will have a 5x square plus 6x. This is equal to 11. And now we have gotten the equation that the question wants us to show which is the equation where the x coordinate of D is going to satisfy. In part 1, we have already gotten the equation where the x coordinate of D is satisfied. So solving this equation should give me the x coordinate. So let's go ahead and do that. So with this equation, I'm going to bring 11 over to the left-hand side. So we have a 5x squared plus 6x minus 11. This is equal to 0. Factorizing this, we have a 5x plus 11 multiplied by x minus 1. This is equal to 0, which means that x is going to be equal to minus 11 over 5, or x is equal to 11. At this juncture, I think I'm going to pause for a little bit to discuss about what the question is asking in the next part, which is actually to explain why the diagram is necessary. Because of the diagram that is given to us, we can read off that the x coordinate of D is going to be a positive number. So based on this 2x coordinate that is supposed to be the x coordinate of D, I know that I'm going to be rejecting this based on the diagram. That is why the diagram is necessary. So this is not applicable based on the diagram. So x is going to be equal to 1. We're going to substitute this back into the equation that we have found in part 1. So we're going to substitute this back into the equation number 1 in part 1. So substituting x is equal to 1 into equation number 1 that we have found in part 1, we have the y coordinate of D as minus half times x, which is 1, plus 17 over 2, and this is equal to 8, and therefore the coordinates of D is equal to 1, 8. This part is just a 1-mark question, so we will not be expecting a lot of solution before we can write down the coordinates of C. And to be able to come up with a solution that is as lean as possible, I believe that we need to make use of two congruent triangles that we can find in our diagram here. One involves AB, and if I were to draw a line down, this is going to give me a right-angled triangle. And next is going to be involving DC, and if I can just look at it from horizontal line here and a vertical line here point of view, we form another triangle here, and these two triangles, they are actually congruent because these are the sides of a parallelogram. So they have the same length and they have the same slope. That is why these two triangles are supposed to be congruent. And making reference to the coordinates of D that we have found in the previous part, we are going to find the length, and which is going to be the same as this length, and this length, which is going to be the same as this length. For this lengthwise, we are looking at B, which has an x coordinate of 7, and for here, there's an x coordinate of 5, which means that this length is going to be 7 minus 5 is equal to 12. And this length is going to be 5 minus the y coordinate here is 0 is equal to 5. So we are seeing this as 12, we are seeing this as 5 since they are congruent to each other. And with reference to the x coordinate of D, we will be able to come up with the x coordinate of C, which is taking the x coordinate of D 1 plus this length here 12. Or we can also write it down as 7 minus 5. So 1 plus 12, this is equal to 13. So this will give me the x coordinate of D. For the y x coordinate of C. So for the y coordinate of C, we're going to make use of the y coordinate of D plus this length. So it's going to be 8 plus 5, or 5 minus 0. And this is also equal to 13. So the coordinates of C is 13, 13.